So Illumina is venturing into long-read sequencing. And this is from a press release last week. It's of a product based on something called complete long-read technology. Now, why is this a big deal? Or what is long-read sequencing technology? And that's what we're going to look at in today's video. So why is this a big deal? In a word, it's competition. But competition outside of Illumina's traditional expertise. Imagine McDonald's and KFC. Both are fast food giants, but both are kind of like different from one another. McDonald's does burgers, KFC fried chicken. But imagine McDonald's started selling fried chicken and competing with KFC. And actually, they do that here in Malaysia. It's very good. But what you're doing is you're going outside of your traditional customer base and you're taking on new competition. And that's what Illumina is doing with long-read sequencing. Traditionally, Illumina is number one when it comes to what is called short-read sequencing, meaning it splits up your DNA into tiny pieces and it reads the DNA molecules one letter at a time. And then using computer software, it joins these pieces together again very, very accurately. So most scientists, most labs in the world, they use Illumina machines. They work. Illumina dominates the world sequencing market. But along comes this small company called Oxford Nanopore. And what they claim to be able to do is sequence all the letters of your DNA up to hundreds of thousands of molecules at a time. Now, Illumina does 300. So this is like 1,000 times, 10,000 times higher resolution than Illumina. It's kind of like comparing HD with 4K. So it has to be said that it's not as accurate. It's still relatively new, but it's cool and it's exciting and it's surprisingly cheap to run. You can actually buy one of these Nanopore devices, run it on your laptop for about $1,000 piece. So it's very, very affordable. And so what's happening is a lot of labs, they already have an Illumina machine. They're looking into long-read sequencing. And I think that's why Illumina is releasing this new product line. What they're saying is, stick with us. We can do the same thing. We can now do long-read sequencing. So that's the big deal with this announcement. Again, it was just last week, but it shows that Illumina is kind of nervous about all these new technologies that could possibly overtake them sometime in the future. And it's great. All this is driving innovation. This competition is driving science and technology forward. But secondly, I'm wondering how are they able to do this? What's behind the technology itself? Because the thing is, Illumina haven't changed anything about their machine, and yet they claim to be able to do long-read sequencing at a higher accuracy than their competition. How are they doing this? And this is where you kind of have to put air quotes on long-read sequencing because it's a hack. It's not true long-read sequencing. The way that Oxford Nanopore do it, it's very, very ingenious. They pass the DNA through a nanopore, and a nanopore is just a tiny hole. And what they do is they pass an electrical current and then measure the change in resistance as each molecule of DNA passes through the nanopore. With each different molecule, you get a different resistance, you different measure, and then you're able to read the different letters of the DNA. Now, the big advantage of this method is you don't have to mess around with your DNA. In short reads, you have to cut them up into small pieces, you have to multiply all these pieces, you have to stick chemicals onto them. But with long reads, with Nanopore, you just dump in whatever you have, and even in small quantities, it just gives you the results. Now, this is why Nanopore is really, really useful, really great for discovering new changes in DNA. It's used in cancer, it's used in COVID, because you get this bigger picture of your DNA. Now, how does Illumina do its long-read sequencing? Well, in short, it doesn't. What it does is it tags your DNA molecules using chemistry, kind of like sticks bookmarks on parts of your DNA string, and then it splits it up, cuts it up, and does traditional short-read sequencing. But the magic happens afterwards. At the end, when the computer uses all these bookmarks as a reference to glue the quote-unquote long reads back together again. And I gotta say, even though it's technically cheating, Illumina does boast a higher accuracy compared to what it calls traditional long read technology. Now, these long reads aren't really long. It's just 1.5 kilobases to 10 kilobases long. It's not like the 200,000 that Nanopore is able to do. But the biggest advantage, again, is that you can do it all on the same machine. Short reads, long reads, you can use the same Illumina machine. Now, what does this mean for progress. It's still early days, and the announcement just came out last week, but I think Illumina is trying to add value to its NovaSeq series, which is the industry standard, and it's a good thing, get more value for your buck. And in comparison, Nanopore is still considered as a research tool. They're very, very cool. They're coming up with lots of new stuff. Just because of that, it's just worth doing a separate video on Nanopore and not talking too much about it in this one. But what do you think? Are long reads the way to go? Is it the next step in the evolution for sequencing technology? Or do you think it's just a gimmick? If you found value in this video, please give it a like. And please have a look at the other one where I compare Illumina and BGI sequencing technologies. Thanks for watching. See you in the next one.